Right, let's have a look at question 13. Let's have a look at the Maxwell-Boltzmann distribution curves to start off with. So, number of molecules up the left and energy along the x-axis. The higher the peak and the further the peak to the left is the lower temperature. The lower the peak and the further the peak to the right is the higher temperature, because more particles have a higher energy. Both curves should go through zero, through the origin, and they do, and neither curve should touch the y-axis, because always some particles, even though there's only a few, some particles have a high energy. This higher energy curve, so the peak is lower, but it should be shifted to the peak should be further to the right than the lower energy curve. So this is the higher energy curve here, and it should end up higher, so more particles should have a very high energy than the lower temperature curve here. The reason the peak shifted when the peak shifted to the left, the reason it's higher is that the area underneath the curve for both curves needs to be the same, because that represents the total number of molecules in the sample, and the sample hasn't changed. If you read down from the peak of the curve, so say for example P, that's the energy that most particles have at the lower temperature. R from the peak is the energy that most particles have at the higher temperature. However, just slightly to the right of the peak is the mean value, so that's the mean value of the particles' energy. The mean energy of the particles at the lower temperature is Q, and just to the right of the peak, S, is the mean value, the mean energy that particles have for the higher temperature. So your answer, which shows the mean energy of the molecules at the higher temperature, your answer is S. Which statement is correct for the higher temperature? The area underneath the curve to the left of EA decreases, so there's the activation energy. So more particles have the activation energy at the higher temperature. So as to draw the area underneath the curve, and more particles for the higher energy. The area underneath the curve, which represents the number of particles that have the activation energy or above, is greater than at the lower temperature. And so the area underneath the curve to the left of EA decreases. The area underneath the curve to the left of EA decreases. That is true, because the area underneath the curve to the right increases. The total area underneath the curve increases. No, the total area underneath the curve stays the same, because that represents the total number of molecules in the sample, and the sample hasn't changed. The activation energy decreases. No, the activation energy is the same. What actually happens is at a higher temperature, more particles have the activation energy, and therefore are more likely to have successful collisions. More molecules have the mean energy. No, in actual fact, the mean energy for S, for the higher temperature, there are fewer molecules about here. That number here, if you could read up from S and where it hits the curve at the higher temperature, there are fewer molecules than up from Q, which hits the lower temperature curve at a higher value here. So the answer is A.